Hello, ladies and gentlemen. Today we are going to take a look at polynomial division, a special type of division called synthetic division. So for this, you're going to need your pen, pencil, notes, and maybe even a calculator. So we've been taking a look at polynomial operations, like adding like terms together, subtracting, as well as multiplying polynomials. You'll notice that the only operation we haven't done yet is division, and that's because division is a little bit special, okay? So let's look at just general division, how you learned how to long divide. Remember the number 200 divided by 12, like how would you figure that out? How would you figure out that problem? Well, you would set up a long division problem. You would place 200 inside that long divide sign here, and you would place a 12 on the outside, and you would ask yourselves, how many times does 12 go into 20? One time. Then you would take 1 times 12 and you'd get 12, and then you'd subtract 20 minus 12 is 8. Then you drop down the 0, and then you'd ask yourself that same question. How many times does 12 go into 80? 6 times, that's 72. And then you would subtract. 80 minus 72 is 8. And we would say that 8 was our remainder. Do you remember doing that? You'd write 8 as like an R8. Then later you also realize, well, 8 would be the remainder that I had out of 12 needed to make a full group. So 8 divided by 12, or 8/12, would be left over. So this idea of division, we wrote it as an R8, then we graduated over to 8 out of 12 is left over, like I just said, and then we could write these mixed numbers. We looked at this long division process, and you could do the same thing with polynomials. You could long divide polynomials just like you long divide numbers. But the thing about long division is, well, it takes a long time, right? That's why they call it long division. So there's another way to divide polynomials called synthetic division, and that's our focus today. Synthetic division is a type of division we're going to use to divide polynomials, especially or only when we're dividing by x plus or minus a number. So make sure that you get this part in your notes, because the setup for synthetic division is something that you've never seen before. You've never seen this process, okay? So instead of doing long division setup, like the long divide sign, and we put the polynomial in here and we're dividing it by this, that's pretty standard. That's your long division setup. You divide out the polynomial, nothing too crazy. But on the other side, synthetic division has a setup that's a little bit different. Notice that the coefficients of the 1x squared plus 3x plus 5 are the only things that you see here. You don't see the x squared and the x anymore. Okay, that's what makes it a little bit easier. Also, the x plus 1 on the outside, in fact, the solution is shown in synthetic division. So, for example, if I put x plus 1 equal to 0, I get a solution of -1. That -1 is that value that I place on the outside of a synthetic division setup. So they may divide the polynomial the same way, but the setup or the way we begin is a little bit different. It looks different. So with the synthetic division setup, we're going to divide out the solution, or the 0 we call it. But notice that the coefficients are the only numbers that we're working with, not the x squareds and the x's. So once you get that setup in there, we're actually going to divide this one to see what kind of answer we get, what kind of quotient we are left with. And we're going to divide it out using that setup. So we're going to do 3 examples. The first one is the one that you just set up here on your page. And I'm going to hit the button. There we go. We are going to divide x squared plus 3x plus 5 divided by that x plus 1. So once again, our setup, we're going to use the coefficients 1, 3, and 5. So 1 represents the x squared, the 3 represents the x, and the 5 represents that plain number. But we're not going to write the x's or the x squareds or the numbers behind them at all. On the outside, we're going to place -1, because that is the solution to what we're dividing by. Now with the synthetic division process, now that we have it all set up, the process is a little bit different. First thing we're going to do is drop down this first number. We have a 1 on the outside of the box. Then the 1 times the -1. We're going to multiply these two values, multiply, and we're going to place it up underneath the 3. -1 times 1 is -1. And now we're going to add those two values. 3 plus -1 is 2. Now we're going to multiply again. The -1 times this 2. -2, and we're going to add 5 plus -2 is 3. Now, what does this answer mean? What does this stuff underneath this line represent, or what does it mean? Well, the last number is the remainder. The number in front of that will always be the plain number value, or the constant. And the number in front of that is the x term. If we had numbers in front of that, we'd say that's the x squared. If we had a number in front of that, we'd call that x to the third. It's that idea of knowing what standard form looks like. So my answer is telling me that I have 1x plus the number 2 plus the remainder of 3 out of, what was I dividing by? X plus 1. This is my quotient. This is what I would get if I divide this polynomial by this one using long division. Now notice it didn't divide out evenly. That's going to happen. That remainder is what makes us add that little fraction at the end. Let's take a look at another example here. So we're going to set this one up the same way. On the outside, I'm dividing by x minus 3, so I'm going to place the solution to that, which is just regular number 3, positive, okay? In the inside, we're going to use the coefficients here of this polynomial. But notice it is in standard form, but do you see how the x to the third term is missing? That's going to be important because when we place our coefficients in this box here, we're going to need to place a 0 for that placeholder. So I have 1 x to the fourth, I have 0 x to the thirds, I have negative 10 x squareds, I have 2 x's, and I have a plain number 3. So we had to add a 0 in there because we were missing the x to the term piece, and we need that placeholder that keeps us dividing out this problem as long as it needs to, okay? So we're going to drop down the first number, which is a 1, and now we multiply. 3 times 1 makes 3. Then we add 0 plus 3 is 3. 3 times the 3 is a 9. Negative 10 plus 9 is negative 1. 3 times negative 1 is negative 3. Add negative 1. 3 times negative 1 is negative 3. Add 0. So that last number, remember, is the remainder. And what happened here, good things happened. It divided out evenly. Smiley face. I don't have to put that funny fraction at the end of my answer. The number in front of that is still the plain number. The number in front of that is the x term. In front of x's, in standard form, I would have x squareds. In front of x squareds, I would have x to the thirds. So when I place my x values or my labels back in here, this is telling me that I have 1x to the third plus 3x squared minus 1x minus 1, and no remainder to add on here with a funny fraction. So my quotient, or my answer to my division problem, is x to the third plus 3x squared minus 1x minus 1. All right, third example. We're going to divide this polynomial by this one. So this was just written a little bit differently. Remember that fractions are division. It's telling us to divide. We're taking this guy divided by this one, just like we would any other problem. So don't worry about the fact that it's written as a fraction. It's still telling us to divide. So let's go ahead and place the coefficients in our synthetic division. So we're not missing any terms here. So I have 1x to the third, then the x squareds, then the x's, then the plain number, the constant. The solution to this is going to go on the outside. The solution to x minus 2 is a positive 2. So positive 2 goes on the outside. Drop down the first term, 1. 2 times 1 is 2. Adding 0. 2 times 0 is 0. Adding 3. 2 times 3 is 6. Adding 2. So I now have this all worked out. Now I just need to remember what my answer means. This is my remainder. The number in front is the constant, or the plain number. X is in front of that. X squareds in front of that. So I would have 1x squared plus 0 x's, so I wouldn't even need to write that, plus a plain number 3, plus a remainder of 2 out of x minus 2, which is what I was dividing by. So this is my quotient for this division problem. Why do we need to learn how to divide polynomials, you're thinking? Don't worry, you'll find out. This is a big part of what we're about to do as we find these polynomial solutions, okay? As we find the solutions to these polynomial functions. This process is going to be something that we use often, okay? So let's just get used to the idea of dividing, and I want to thank you today for taking good notes. We're going to practice on this, and you'll get better as you do more and more practice, okay? So again, thank you for taking good notes. Kincaid out.